This topic is in fact a continuation of the lesson that I discussed in the previous video. Before we proceed, let us have a short recall about the theory of continental drift. Alfred Wegener, a German meteorologist, proposed the theory of continental drift. According to him, the continents were once united in a single landmass called Pangaea, a Greek word which means all earth. Pangaea broke into smaller pieces known as the continents, and these continents drifted apart and moved away toward their current locations. Wegener presented some evidence to support his claim. This evidence include the continental jigsaw puzzle. According to him, the edge of one continent surprisingly matches the edge of another continent, just like the South America and the Africa, their edge fit together. Same with the India, Antarctica, and Australia, which match together. Another one is the fossil evidence. So similar fossils of organisms from the remote past are found in the different continents. Then we have the rock and mountain correlation. Identical rocks and mountain structures had been found on either side of the ocean. And the paleoclimate data. The presence of glacial striations in the tropical climate or in places with tropical climate, and the presence of cold in some places with cold climate. To sum up, we have continental jigsaw puzzle, the matching fossils or the correlation, rock and mountain correlation, and paleoclimate or the ancient climate. However, the question as to how the drifting took place left the continental drift theory blurry. Despite the evidences presented by Alfred Wegener, his idea that the continents were once joined together was not accepted by the scientific society until the 1960s. Why? He was not able to explain how the drifting took place. This made scientists conduct further studies and search for the answer. During the 1950s and the 1960s, new techniques and modern gadgets enabled the scientists to make better observations and gather new information about the ocean floor. The use of sonar, a device that bounces sound waves off underwater objects and then records the echoes of these sound waves. Sonar is used to map the mid-oceanic ridges. The submersible Alvin found strange rocks shaped like pillows or like toothpaste squeezed from a tube. Such rocks can form only when molten material hardens quickly after erupting underwater. Scientists found a system of ridges or mountains in the seafloor, similar to those in the continents. These are called mid-oceanic ridges. One of these is the famous Mid-Atlantic Ridge, an undersea mountain chain in the Atlantic Ocean. It has a gigantic cleft about 32 to 48 kilometers long and 1.6 kilometers deep. The ridge is offset by fracture zones or known as the rift valleys. Early in 1960s, an American geologist named Harry Hess studied mid-oceanic ridges. He suggested an explanation to the continental drift theory together with Robert Dietz. So the process of seafloor spreading occurs at the mid-oceanic ridge. So as you can see in the illustration, the hot magma from the mantle rises and erupts. Then the materials flow sideways, carrying the seafloor away from the ridge. So as this process continues to happen, cracks are created and the magma will flows out through the cracks. Then when this magma cools down, it will solidify and become a new rock, or what we call the new ocean floor. So as simple as that. So again, in Tagalog, let me explain in Tagalog. So dito po, ito yung site or the place where the seafloor spreading occur, or known as the oceanic ridge. Dito po sa oceanic ridge nagaganap ang seafloor spreading. So here class, the magma at the mantle rises or erupts. So, pag umangat na yan, it will flow sideways. So, as it flows sideways, it will push this seafloor away from the ridge. Kumbaga, since nag-accumulate dito yung material, the accumulation of the material here, okay, it will take up space here at ipupush niya itong material sideways. So magmo-move itong seafloor here papalayo sa oceanic ridge. Ganon din sa kabila. So when the magma solidifies, pag yung magma na yan ay oceanic and continental. On the other side, we have both oceanic plate. At the middle is the site of the seafloor spreading or the oceanic ridge. Di ba nga, I discussed before that the geologic features that will form in the divergence of oceanic and oceanic is what we call the mid-oceanic ridges. So it is where the seafloor spreading process happens. So just like what I have discussed a while ago, that the new material formed here in the ridge pushes the old materials in the seafloor away from the site or away from the ridge. So the age of rocks or the age of the seafloor far from the oceanic ridge is older than the seafloor near the oceanic ridge. Again, the age of the seafloor away from the ridge is older compared than the age near the seafloor. Kumbaga, pag mas malapit, mas younger, pag mas malayo, older. Alright, so again, seafloor spreading process occurs along divergent boundary. So as the materials here, as the seafloor moves, it might interact with another plate. Like example here, the oceanic plates. The edge of these oceanic plates collide with the edge of another continental plate. So kapag nagkaroon ng convergent or collision, so what will happen is that the leading edge of the oceanic plates undergo subduction. wherein the plate is being destroyed and formed into a magma. And then it makes the ocean floor wider. But if the subduction process is faster than the seafloor spreading, then summarize, rocks are younger at the mid-ocean ridge. Those far from the mid-ocean ridge are older, and rocks at the ocean floor are younger than those at the continents. Just continue watching as I am going to explain to you how you're going to answer or accomplish or perform the activities provided in your module for this week. Alright, so I'm going to explain to you how to do activity 1, which is the simulation of seafloor spreading. So you will need a folder, then a coloring material, or in my case, I just use the pencil pen to draw. So you're going to draw the continent, just follow the instruction in your module. So then you have to, here's the folder. So I made 3 slits at the middle, at the end, and another end. Then you need also a bond paper. So fold the bond paper into 2. questions 1 to 7. That's 2 points each, 14. Then this one, activity 6 points with a total of 20 points. Okay. So again, class, you will be answering 2 activities only. Activity 1, the simulation of seafloor spreading. Then activity 2, so this will be 8 points for activity 1, 7 points times 2 for 14 plus the picture of your output, so 20 points. So now you have the idea kung ano yung mga slit na yan, anong ni-represent nito, then yung sa gilid. If you watch the video, then you already have the idea and you could be able to answer the questions here correctly. So this is 20 points for activity 1, then 8 points for activity 2. Then also you have to answer the pre-test. I will be sending the link of the test in your GC. So that's all. Then next week will be week 8, the last module that we're going to discuss. So thank you for watching. I hope that you learn from my discussion in this video. Thank you so much and have a nice day.